Hi class, today we're going to be reviewing for our Unit 1 assessment. In the first section, we're going to be comparing rational numbers. If you notice, the first two are absolute value and the last one is just a rational number, a whole number, 96. The question says, solve, then circle which one of these is the greatest. To solve the first one, an absolute value of negative 336. If you remember from our unit that absolute value is always positive. So whatever numbers are in those bars just becomes the positive number. 336. If it's already positive, we just take it out of the bars and rewrite it, and then we have 96. Which of these is the greatest? 336. Okay, now we're going to be comparing using less than, greater than, or equal to. If you need to, draw a number line to help you visualize the problem. In the first two, we're going to be comparing the rational numbers negative 5/8 and negative 3/8. Which one is more negative? Well, negative 5 is more negative than negative 3. Negative 5 would be down here somewhere, and negative 3 would be around here. So negative 5 is more negative, so it would be less than negative 3/8. We're going to do the same thing for negative 3.7 and negative 9.2. Negative 9 is more negative than negative 3, so negative 9 is less than negative 3.7. We could also say negative 3.7 is greater than negative 9.2. In the next section, we're going to put these rational numbers in order from least to greatest. You have to pay attention to what the question is asking you to do. The first thing to do, the easiest way I feel, is to put all of them in the same form. Let's put them all in decimal form. 3 divided by 2, or 3/2, is equal to 1.5. 1.75 is already in decimal form, so I can just leave it. Negative 1/2 would be negative 1/2, negative 0.5. 0 remains the same. And this rational number is already in decimal form, so I'm just going to leave it. Now we have to look and put them in order from least to greatest. Negative numbers are always least. So we're going to look, we have two that are the same. So let's write those first. Negative 0.5 and negative 0.5. We've used those. The next least number is 0. And then 1.5 and 1.75. These rational numbers are now in order from least to greatest. Now let's practice making equivalent rates and ratios. The first question says, circle the ratio of 2 teachers to 42 students written in lowest terms. So I have to make this in lowest terms. The first thing I'm going to do is write 2 teachers to 42 students in a fraction form. I'm then going to put it in lowest terms by dividing both the top and the bottom, the numerator and the denominator, by the common factor of 2. And I get 1 over 21. The only one I see that looks like that is 1 to 21, which is just a different way of writing 1 fraction 21, or 1 over 21. Okay, the second one is a little more tricky. Circle the rate that is equivalent to 64 miles in 2 hours. Even if I reduce that to lowest terms, it would be 32 to 1. I don't see an answer that looks like that. This can't be it because it's 1 to 32, not 32 to 1. The next best way to try and do this is to put them all in decimal form and see which ones are equal. "64 divided by 2 is 32. Are any of these rates equal to 32 when I divide the numerator by the denominator? 2 divided by 64 is 0.003. That's not equal to 32. 1 divided by 32 is equal to 0.003. That's not equal to 32. 32 divided by 2 equals 16. That's not equal to 32. But 96 divided by 3 is equal to 32. So this rate is the one that is equivalent to 64 miles in 2 hours. Now they're going to ask us to circle a table that has equivalent ratios. It's called an equivalent ratio table. To do that, I'm going to do what I just did in the problem above. I'm going to put each of those fractions into decimal form so I can compare. 3, think of this as a fraction, 3 divided by 8 is 0.375. 6 divided by 16 is 0.375. 12 divided by 32 is 0.375. And 30 divided by 80 is 0.375. All these rates in the table are equivalent, so this would be an equivalent ratio table. Let's check the next table. 1 divided by 2 would be 0.5. 2 divided by 3 would be 0.66 repeating. I can already tell that this table is not equivalent, but I'm going to keep going. 3 divided by 4 is 0.75, and 4 divided by 5 would be 0.8. This table is not an equivalent ratio table. Now we have to practice unit rate. It's also called constant of proportionality. They're asking us to circle which of these is the best buy for Kleenex boxes. Remember, we did this one on the board in class. If we went to Mark's or BJ's or Giant Eagle to see who had the best buy for Kleenex. Let's look at, remember, we always put money on top. So $42 for 35 boxes. Or is it better to buy for $55, 50 boxes? We can't compare them the way they look right now, so let's put them in unit rate. We can do that by making 1 on the bottom. By putting 1 on the bottom, we're always looking for unit rate. We can then cross multiply to find our answer. An easy way to find unit rate, if you already have the 2 numbers that you need, is just to do 42, money on top, divided by 35. When I do that, I get $1.20 per box. If I do 55 divided by 50 boxes, because I just want to know what it is for one, 55 divided by 50 will give me $1.10. $1.10 per box. This would be my better deal. That's where I want to go shop for Kleenex. Be careful with that one because it is very easy just to divide 42 divided by 35. But sometimes they don't want unit rate. They don't want it for 1. Look at this next problem. Tammy drove 385 miles in 7 hours. At this rate, how many miles will she drive in 8.5 hours? We can't simply just divide the numerator by the denominator on this one. We have to set up a proportion. So let's put miles on top and hours on the bottom because we usually say miles per hour. 385 miles in 7 hours. Remember, different up and down, same units across. So I'm going to have miles here and hours in the denominator. They want to know how many she will drive in 8.5 hours. So I have to put that where hours go. This is what I don't know, so I have to solve for my variable. To do that, we cross multiply. 7x equals 385 times 8.5. That equals 3,272.5. But remember, we don't want to know how many it is for 7x. We just want to know x. So I divide each side by 7. The 7's cancel out, and I'm left with 467 1/2 miles in 8.5 hours. Now the bottom section says write an equation that represents this proportion. What does that mean? That means use your variable to write an equation. We do that automatically when we cross multiply. This is our equation. 7x, when we multiply 7x, 7 times x in our cross multiplying, equals 3,272.5. That's our equation that they want us to write. That's just what we get when we cross multiply. Don't get confused by that. It's very simple. Okay, now we're looking at a graph to see if we can find the constant of proportionality. Class, what is that also called? Unit rate. We want to know what is the profit for 1 tub of cookies. We can't really tell that from the graph because we can't really tell where 1 is over here. It's not very clear. So what we do is we look at the graph and we first find a point that we can tell it crosses the x-axis and the y-axis at a point that is very easy to identify. That point is right here. 10 tubs makes the cookie sale profits $18. They don't want to know what it is for 10 tubs. The question is asking for unit rate or constant of proportionality. But we can reduce that. So let's put the money on the top. It's $18 for 10 tubs. So how much would it be for 1 tub? Well, because we are doing unit rate, we can cross multiply if we want, but all we have to really do is take 18 divided by 10, and we will get $1.80 per tub. The next question asks what the profit will be if we sell 20 tubs. Well, there's 2 ways to do this. We can take $1.80 for 1 tub and multiply it by 20, and you would get $36. Or you can also set up a proportion. To do that, we would take 18 over 10, but they don't want to know that. They want to know how many it is for 20 tubs. Remember, this is money and this is tubs. So I can set up my proportion and cross multiply, and I would get 10x equals 18 times 20, 360, and then I can divide by 10 and get the same thing, x equals 36. Remember, in math, there's more than one way to solve a problem. That's it for the review. Please make sure you can do these problems. You will see ones just like this on the test. Study. Good luck.